All right, good morning. Welcome back to CS 125. It's Friday. How are you guys feeling about it being Friday? Good? Tepid at best. Maybe that's because you guys are working on a midterm review over the weekend and MP2, so I guess I'm to blame for that. So today we are going to launch ourselves into a new topic. So up till this point in the class, we've been focused on introducing and practicing with the basics of what we refer to as imperative or declarative programming. We've introduced you to loops. We've introduced you to conditional statements and expressions, and to arrays and to variables. And now what we're going to do is we're not going to put those things aside, because we're going to keep using those ideas and those constructs throughout the rest of the class. But today we get to start talking about one of the features that makes Java distinctive, which is its object system, or Java objects. Java objects really aren't a new way of writing computer code. They're a new way of structuring computer code. They're a set of conceptual ideas about how we organize information and about how we organize our computer programs. And again, this is something that made Java distinct. This is something that Java contributed. It wasn't the first language to do this, but it was one of the first really highly popular languages to introduce this type of object system and some of these ideas. So that's what we're going to do. Throughout the rest of this semester, I don't want you to think that we are, done with imperative programming, because the methods that you write when you create and implement objects on the homework and on our MPs are going to continue to use those imperative ideas. So we're going to see those over and over again. We'll get lots of chance to have more practice with those. So roughly, here are the three main things that we're going to talk about throughout the rest of the semester. Because one of the cool things about objects is they sort of bring together some of these other ideas. So we're going to talk about algorithms. This is a core conceptual concern of computer science as a field. How do we solve problems? And in particular, how do we solve problems using a computer? Because that's why you're all here. You're not here because you have a general interest in problem solving. You're here because there's this beautiful tool that we created called a computer that is going to allow you to solve problems in new ways and much more efficiently. So we're going to talk about how computers solve problems. We're going to also talk about data structures. So these two topics are really intimately related. The course here at Illinois is called Data Structures, and I've always felt that that's a really terrible name for a course like that, because what it's really talking about are data structures and algorithms. We structure data in certain ways frequently because we can then run a particular algorithm on it and do something efficiently or quickly. So that's one of the reasons to use things like lists, which we'll talk about in this class, trees, which we'll spend a fair amount about talking about, arrays and hash maps and things like this. These all exist because they have desirable properties, particularly for when working with particular types of data or implementing certain algorithms. And then we're going to continue to give you practice, and this is something that we'll touch on from time to time. We'll get to this hopefully a little bit later today when we talk about how to prepare for the midterm, but how to develop software, how to write good code, practices and principles that the software development community has built up over the years that lead to good results, that will help you complete the MPs, that will help you when you build bigger projects and bigger systems, that will prepare you to work in industry or to work in a research lab on much, much, much bigger systems and bigger pieces of software. Okay. So we've already introduced one idea when it comes to how do we structure our programs. That idea was functions. And we've talked, a lot of the homework problems and what you're working on for MP2 is essentially implementing functions. This is a way to create reusable logic that we can then use in different parts of our program. So this is one of the principles that we talked about when we talked about how do we structure a good program. So breaking our code into reusable pieces, so we've been doing that. Combining state and behavior. So this is the thing that we start talking about today, because objects really start to bring these two concepts together. Data and algorithms, sort of the two core concerns of computer science. I was actually thinking, if you think about the name computer science as a field, and you take the computer part, you can say sort of computer algorithms. You take the science part, data science. So algorithms and data. Computer algorithms, data science. These are two of the things that are really animating the field right now. And we want you, by the time you finish this course, to be able to both understand a little bit about how to work with unstructured data and also how to write algorithms to process that data that do useful things. Documenting our code, okay, we're gonna continue to do that. Reusing pre-existing solutions as much as possible. We'll get to these things, right? We're already giving you a little bit of practice with using check style, and we'll talk later in the class about how to use imports and libraries appropriately. And also publishing your code. So that's one thing that you had a chance to start practicing with this week in lab, right? Taking a project, forking it, making some changes, pushing it to GitHub. The final step in that, closing that loop, is sort of contributing back to the project. That's not something that we'll talk about in this class, but at least you've gone through some of that workflow, right? This is how people online, including me and other people, share ideas and share solutions with each other. So at this point, I talked about this when the course began. I said, programming is this really intensely creative activity. I think there are some people who think the programming is boring, that it's this rote thing that, socially awkward people do in cubicles, dark cubicles all across the world, right? There are these people sitting there hunched over, tabbing away, that aren't particularly interesting people. They're just doing this really boring stuff. It's like the movie Office Space, right? Like I'm updating software for the Y2K crisis, right? So most of the people that think programming is boring aren't doing it very well, right? They're either working on the wrong problems, they're using bad tools, or whatever. If you do it well, it's incredibly fun. And as I said before, it's an incredibly whole brain activity. Up till this point, we've been really sort of focused largely on the left brain part of programming. But when we start talking about objects, we start talking about design. Because when you start talking about, how am I going to structure a particular object, you have to start making design choices. And that's where this becomes the right brain part, right? That's where you start making choices where, both are correct, but it's possible that one leads to a more beautiful result. It's possible that one choice leads to something that you are more satisfied with, that someone else can more easily use, that your boss is going to smile when they see, oh, this is really elegant, I like this, right? I like how you've structured this, right? Again, both being correct, but there being design aspects to our choices. So again, when we talk about object modeling, on the MPs, frequently we have to sort of give you enough structure so that we can grade your code. But in class, I want us to start interrogating some of these questions of, how do we design a particular object to accomplish a particular problem? And there aren't right answers. There are sometimes better and worse answers, but we need to be creative. We need to use our imagination to think about how things get used. We need to think about all aspects of the problem. That's an important part of designing objects well, and applying some level of intuition, right, into the problem space. There's one more thing on here. Oh, yes, visualization. Good. Okay. So what are objects in Java? Objects bring together state and behavior. So an object acts in some ways like a variable. And we will work with instance variables that refer to objects, to an instance of an object. So on some level, an object acts like a variable. But as you've noticed when you've been working with strings, that variable carries around with it these methods, these functions, behavior, things it can do. So a Java string not only stores a sequence of characters that are put into structured into some sort of meaningful order, but you can do things with it. I can split it. I can make it all uppercase or lowercase. I can, all these different methods that are attached to the string object. I can convert it to an array of characters. We've been using these methods. And so that's the really kind of clever thing about objects. When we talk about objects, we're always going to try to identify two things. So first of all, what data does it store? It doesn't have to store data, but most objects do. So most objects include, there's some state that goes along with it. For a string, for example, internally, a string stores an array of characters. When we talk about other objects, what they store is entirely up to us. We can define our own objects. When we use other objects that other people have designed for us, we'll still have to think about, what's inside, right? What information is it encapsulating, or what is it storing? And then what does it do? Or what does it allow me to do with it? So we looked at strings. This is the object you guys are most familiar with, and you've been using string methods. When you talk about other types of objects, so we have an M key coming up where you'll be working with sound. And you're using a library that somebody wrote that allows you to work with audio. And that library allows you to do things with it, like, you know, extract one track or extract the other track or whatever. So, you know, part of the reason that we create objects is to provide useful algorithms or useful methods that operate on the data inside of those objects. So these are the two things that objects bring together: state and behavior. And, you know, when I started thinking about this today, you can really think of objects as sort of uniting the core concerns of computer science. So state, data, it's a sexier word for state these days, and behavior, algorithms. You know, every function you write is an algorithm. They're not all super interesting algorithms. We'll talk about some more interesting algorithms later in the semester, but every function you write is an algorithm. It does something, solves some problem, transforms data in some way. What objects do is they unite these two things. So now, every object that I work with not only brings along data that I can structure in a really flexible way, but it also brings along algorithms with it. It allows me to do things to it. So here's the official definition from Wikipedia. It says, in the class-based object-oriented programming paradigm, which we are entering into today, object refers to a particular instance of a class, where the object can be a combination of variables, functions, and data structures. And really, that definition is a little redundant. Variables and data structures are kind of the same thing. An object can store data. It can also provide methods or functions. All right, so let's look at one. You guys have seen these on the MPs. And internally, we've been using these on the homework problems, although we haven't been showing them to you. But now we're kind of zooming out. We've been showing you little pieces of the files that you've been working with, and you've been focused on, you know, completing these specific functions. But there's some context to this that you haven't understood. And so now we're zooming out kind of another block level. We're going to talk about the class itself. So a class in Java defines how a particular kind of object or a particular instance of an object is going to behave. So you can think of the class definition as sort of a blueprint that is used when I create objects of a particular type. It sort of says, so for example, here's one. This is a class called person. We want to name classes using the same sort of intuition that we use to name other things in Java. You'll notice that the name is capitalized. Remember, in Java, object types are capitalized. Primitive types are not. So from now on, we're going to be looking at a lot of capitalized variable types because we're going to start talking about objects. So this is a class called person. And at that point, I open a block. And what's inside that block defines both the state or the data that that object can contain and the methods that that object provides. So right here on line 2, you see something that looks a lot like a variable declaration, right? It's outside of a function context. We've never seen this before. So this is something that's known as an instance variable. This says that every object of type person has a property called name that's of type string. Okay, on line 3, every instance of type person will also have a property or an instance variable called age of type int. I can initialize these if I want to. I don't have to. If I don't initialize these, they get the sort of standard uninitialized values. And next time we'll talk a little bit more about a more sort of canonical way to initialize object instance variables, which is that there's a special function that runs every time an object is created that we'll talk about on Wednesday next week, because Monday we're going to do midterm review. Okay, so line 2 declares an instance variable called name of type string. Line 3 creates an instance variable called age of type int. On line 4, I'm showing you some behavior. So this is a function. It's defined. It says every person, every instance of type person also has a method called print name. So if I give you an instance of type person, you can call this method called printName. And what is that method going to do? Okay, so there's some new syntax here. I see a system.out.println. I've seen that a lot. But now I see this thing called this. This is new. This is literally new. Yeah, what's going on here? Okay, so we'll come back to this. But some of you might start to think about what's happening. One thing that really tends to trip people up when we start talking about objects is that every single instance of a particular object can have different instance variable values. So if I create 10 different instances of type person, every one of them has its own name. Every one of them has its own age. They can be different from each other. If I change one, I don't change all the others. There's an exception to this, which we'll talk about in a few lectures. But for instance variables, every instance of the type person will have its own age and name. And of course, that's what we want. So again, and this is a really sort of simple little toy example, but here's an example where we're starting to see the power of objects to structure data. A person, most people have a name and an age. Everybody has a name. Some of the names are formatted differently. A name and an age. These are both properties of a typical person. We could, spend 5 minutes thinking of other things that people tend to have, and we could add them to this object. And what the class is doing is it's bringing all this data together and it's storing it in one place. So now, when I talk about a particular person, I can, determine what their age is. I might have an algorithm that says, I want to contact all the people, in my program that have age over 20 or something like that, or over 21, right, for obvious reasons. I might want to write something that prints off everybody's name. So on some level, objects are a data structure. I'm bringing together two pieces of data about a person that belong together. Every one of you has a name and an age attached to you. This class allows me to model that. So a lot of the time, what we're using objects for is to model information. I have just said all of this. Okay, but I'll put it up just in case you guys want to questions at this point. Yeah. Yeah, so I'm trying to be precise about this. So the question was, is there a difference between instance and object? Not really, but I'm going to try to use the word instance, and I think it'll be clear why, right? Instance versus class. A class is the blueprint that defines how all of the instances of that object will behave. An instance is a particular object of that class. Yeah, great question. So one of the features of Java is that there are some languages where after I compile my code, as the program is running, I can actually make changes to the structure of the object. And this is important. I can, of course, change someone's name, right? I can, well, I don't know. Of course, maybe not. I mean, there is a legal way to change your name. I've done it once. But you can, as the program is running, for an instance of an object, I can change its name and I can change its age. I may need to change its age periodically, right? But I can't restructure the object. I can't say, oh, as the program is running, oh, I forgot that, a person should also have a birthday, and I can add that to the object. I have to do this when I'm building the program, when I'm developing the program, when I'm compiling the program, to use the workflow that we talked about last time. Okay. So object terminology. So again, I'm going to try to use instance. So an instance of a class is an object of that particular type. It means that I took the blueprint. The blueprint is, this is a good metaphor, where the blueprint is not the house. The blueprint is just something on paper. There is no house here yet until I create an instance of this class. So there's no person. Just defining a class called person, just creating a blueprint, does not create any people. To do that, I use this syntax on line 8. And you have seen this before when we talked about strings, because strings are actually objects. So to create a new instance of an object, I use this new keyword. On the left side of that statement, on line 8, is a variable declaration that looks pretty familiar. It says, Java, I want to create a variable called Jeffrey of type person. The person is capitalized because I'm using an object type. And on the right, what I'm doing is I have this new keyword, which is used to create new objects in Java. And then I have something that almost looks like a function call. And it actually is a function call. And we will come back and talk about this next week. I'm calling a special function on this object that's called a constructor. What it returns is a new instance of that type. So Jeffrey ends up receiving a new instance of type person. All right? So person is the class. Jeffrey is an instance of that class. And if I wanted to, I could create many, many instances of the class. One blueprint, lots of different things that I create using that same blueprint. Then I'll share this structure. All right, so we've seen this already. So now the question is, given an instance of a particular type of object, how do I get at its instance variables and methods? And in Java, I do this using dot notation. You've already been doing this with strings. You didn't necessarily fully understand what was happening. But here's an example. So on line 8, so from lines 1 to 7, I have my blueprint for the person class that describes the instance variables and methods that that class is going to have. On line 8, I create a new person, a new instance of a person. And I save that into a variable called Jeffrey. And then on line 9, I'm accessing one of Jeffrey's properties. I'm setting one of my instance variables. So I said Jeffrey.age is equal to 38. That's actually a bug on the slide. That should be one bigger. And then on line 10, so you'll see on line 9, I'm accessing that instance variable. I'm setting it. And line 10, I'm accessing it as part of a print statement. So in this case, I can both set and get the value of age. I'm working with age here very much as if it was an integer declared locally. That's what I can do. Age is of type int. If I tried to assign a string to age, I would get the same kind of compiler error that you've seen before. So instance variables are treated the same way in Java as a local variable. Yeah, question? You have to speak up a little bit. Yeah, so we'll come back and talk about that next week, right? The answer is no. So the question was, are all of the variables and methods in this class by default public? No, but we can access them here, right? Yeah, it's a good question. We will talk about what we call visibility modifiers next week. I didn't introduce them today intentionally. Okay, great. So let's play with this guy a little bit. Here's the example that I just showed you. And if you run this at your seat, you can see that it will do what I expect. I can also change this to be 39. And that works. And again, if I tried to set this to like a string or something, say I use the string 39 rather than an int, I get a compiler error. So the compiler is still enforcing the fact that the type of the instance variable age is int. I can also set my name to be, here I'm printing off age. Age prints as 0 because 0 is the default value for an int in Java. If it was a double, it'd be 0.0. If it was a string, it'd be null. So let's do this. Let's say, set my age correctly, and then I'll print off my name, just null. That's been second. Yeah? Ah, great question. So what happens if I just print Jeffrey? What do you think? I mean, in a beautiful, perfect world, it would just automatically format the data for me, and it would be like, Jeffrey is 39, right? In the world we live in, interesting. Yeah, this is going to make more sense in a few weeks. What's that? What is that? Is that the question? Yeah, so clearly it's not Jeffrey. That's some gobbledygook, right? Yeah, that's not me. I mean, at that particular moment, in this particular program, that is me, right? I don't want to talk about this in detail today. But you've seen this before. Where have you seen something like this? Some of you may have seen something like this printed off in the past when you tried to print what? An array. Yeah. So what Java is printing here is information about this reference. And it's actually printing some information about the memory location where this data is stored. That is because, and again, please don't freak out if you don't understand this. We will explain this. That's because this class has not told Java how it wants to be printed. There is a special method that we will talk about called toString that I can define on this class. I could do it right now, but I'm not going to. That would then cause me to be able to tell Java exactly how I want this class to be printed. If I don't do that, what's happening is it's using a different toString method that is just printing off this fairly unhelpful information. Okay, that's as much as I want to say about that right now. But it's a great question. All right. So the instance variables that I define on my Java classes can be primitive types. They can also be other objects. So here's an example where you're starting to see how I can design a system of objects to model or represent certain information. So what do I have here? I have two class definitions. I have two different blueprints. The first one, from line 1 to 4, defines dimensions. It says, I want to be able to create an object of type dimensions that has a width and a height. And you can imagine that there's a lot of different things that have these dimensions, particularly if I'm talking about two-dimensional space. So a table has a width and a height. A room has a width and a height. A sofa has a width and a height, right? My dog, depending on how he's lying on the floor, has a width and a height, right? Might change over time. Then I also define a second class. So this I'm now going to use to represent a room. Imagine that I'm using this as part of some sort of drawing program where I'm allowing you to kind of like move things around in your house. So the room has a name. That's another object. And then it also has an instance variable called dimensions. So I might want to name the room in a meaningful way to say this is my living room, and then assign dimensions to the living room. It's like 10 by 12 or something like that, right? If you follow the trail downward, just want to point this out. So if you start at any object, and you take its instance variables, and you look them up, and then you take any of their instance variables and look them up, you're always going to reach either a primitive type or an array of primitive types, eventually. So what would happen here? I would look up dimensions, and I would see, oh, okay, dimensions is an int. And dimensions instance variables are 2 ints. So I've hit a primitive type. If I look up a string, what am I going to get? Internally, a string is represented how? An array of characters. Yeah, so again, I've hit a primitive type. In this case, I've hit an array of primitive types. So if you follow sort of that trace downward, you're always going to get to a primitive type eventually. The only way that Java really knows how to store information is through primitive types. All of the objects we use are built from those building blocks, right? And they're built from other objects that are also built from those building blocks. All right, so now one frequent source of confusion when we start talking about objects is what happens when an object is created. So you might think that when I create a new room, which I'm doing on line 9, do I automatically get a name and a dimensions object along with that room? And the answer is no. You can set things up so this happens, and we'll talk about how to do that next week. But by default, after I create my new room on line 9, if I put a print statement in here, dining room dot name, that's going to print null. I'm going to do this. Yeah. So when an object is initialized, unless I do more work, any other objects that it needs aren't initialized. So name is going to be null. What do you think dimensions is going to be? Also null. I have 2 null references. If I want to create those objects, I can do that. Here's one way to do it. So on line 8, I create an instance of type room called dining room. I see the new keyword, and I see the type. And then again, I see this thing that looks like a function call that will make more sense next week. On line 10, what am I doing? So this is sort of interesting. I'm setting the instance variable dimensions, which is of type dimensions, on my instance dining room to be a new dimensions object. So this is completely okay. I can set both of them, actually. I can say dining room dot name is equal to new string. Let's create an empty string for that, create the dimensions, and then at the end, and you'll see this sometimes, so this is, now I can use double dot notation. So I have an instance variable called dining room of type room. It has an instance variable called dimensions. So I take my instance variable dining room, I access the instance variable dimensions, and it has an instance variable called width. And I can set that. So this will work fine. And then if I print it off, yep, we have to be able to type dimensions, not width. Yeah. So again, this may seem sort of onerous and irritating that you would have to do this. Next week when we talk about constructors, we'll see the right way to do things like this, right? Or the right way to do initialization. Okay. So again, I just want to go back and point out something we talked about, I pointed out at the beginning, which is this idea of objects as data structures. So objects are really designed to bring together related pieces of information, right? So in this case, my dimensions, it has a width and a height. This is a two-dimensional dimensions. If I wanted to make it three-dimensional, I could add, well, I have to change length to width, or sorry, height to width, and I could do a height. So now I'm modeling something in three-dimensional space. If I wanted to make this more accurate, I could replace those with the ints with doubles. So these are the type of considerations that you're thinking about as you start to use objects to represent information. But again, the nice thing is that that int, that width, length, and height are now all bound together. They are structured. They belong to the same instance. So I can send you a dimension, and it carries along with it all of the information that you need to use it, right? To do something like, oh, I'm going to compute the area, or the volume, or whatever. All right. So we've looked at instance variables. Now let's look at instance methods. Very similar. So when we saw on line 2 and line 3, what you're seeing is a variable declaration that's very similar to what you might see in a function. And down here on line 5, you're seeing a function declaration. When you have done the MPs, all of the function declarations that you've made have been on object classes. We didn't talk about that. Was kind of up at the top, and you were encouraged to sort of ignore it, but that's there. When you submit your homework on Prairie Learn, behind the scenes, what we're doing is we're taking the function that you provide, and we're sticking it into a class, and then we're compiling it and running it, right? So Java always requires a class definition in order to define a function. All right, so what do I have on line 5? And I can look at this very similar to what I've done before. Okay, this is a function called area, takes no arguments, returns an int. All right? And so this is a little bit new in the sense that this function takes no arguments. You might be thinking, how do you compute the area of something without knowing the width and height? But this is what's cool about objects. Every object instance method has access to its own data. It has access to the instance variables that are defined on that instance of that class. So when area runs, it can look up its own width and height for that instance of that object. The way we do this, and this is explicit, is we use a keyword called this, right? So just sort of jump ahead for a minute, and then we'll come back. So instance methods can refer to the data that's contained in that instance of the object using this. So what's happening here is that this method called area is using its own width and height to perform the calculation. So I can create a dimensions, I can set the width and height, and then I can call dot area on it. And when I call dot area, I don't have to provide any arguments because the object knows, the instance knows what its own width and height are, or it can look them up. So essentially I can say, return this dot width times this dot height. And I'm correctly computing the area despite the fact that you have provided me with no additional information. All right? So let's see how this works. So I've got here a class, I've got a dimensions class. I had the width and the height that I used before, and I've defined a single method called area. So on line 9, I create a new instance of type dimensions. Lines 10 and 11, I initialize its width and its height. I just set them to 10 and 20. And now, when I run line 12, what is this going to print? So I'm calling this method right here called area. It takes no arguments. When it runs, it's going to say, OK, what is my width? What's this dot width? What is my height? What's this dot height? I'm going to multiply those two together and return that value. So what I'm going to see here, if I run this, it should print 200. Let me try to make this more explicit by creating another example, another dimensions instance. So now what's happening? So now from lines 9 through 11, I'm creating an instance variable called example of type dimensions, and I'm setting its width and height. And then I create a second instance variable of type dimensions called another. I set its width and height. Those two variables, those two instance variables don't share any data. They're two separate instances of the object. Each one has a width and a height. Just want to try to make this very clear because this is something that trips people up when you start working with objects. So what's going to happen at the bottom? Line 15 is going to run. It's going to run area, and that call to area is going to look up the width of the height for the instance variable example, which I've set to be 10 and 20. When I make the call on line 16 to the same function, it's going to look up the area, it's going to look up the width and height of another, which I've set to be different, 20 and 20. So the first line will print 200, the second line will print 400. Uh-oh. What did I, oh, I'm still setting an example, sorry. Bad professor. All right, there we go. Good. So you can see here that one of the things that's cool about objects and powerful about objects is that I'm providing common behavior across a whole range of objects. So essentially, every instance of dimensions knows how to compute its width and height. Those values can be different, but the logic is the same. So for example, when you split a string, the algorithm that splits the string is the same regardless of what's stored in the character array. So if your character array, contains one set of characters, the split does one thing. If it contains a second set, it will do something different. All right. So we talked about a little bit about this. This always refers to the instance that is executing the method. So when I ran this the first time, when I call area on line 15, the instance that I'm calling it on is example. And so this refers to example. So this dot width is example dot width, which I set to 10. This dot height is example dot height, which I set to 20. When I call area on line 16, the instance is another. So instance dot width is another dot width. Instance dot height is another dot height. This dot width is another dot width. All right. Good. Wow, I just did something like this. That's awesome. Okay, good. So one of the things that we frequently use objects for, right? So you might be thinking, like, why, right? And we've talked a little bit about this, but just let me reiterate sort of toward the end of class, is to model real things. There are entities in the world that software programs frequently want to deal with. You can think about the types of programs that you use on a daily basis. A lot of times internally, they're modeling information about the world, right? They're modeling information about people, right? Facebook, for example, probably has lots of different classes to represent information about users of the site. You can imagine what might I want to know, or what might Facebook want to know about a user, other than everything, obviously, but, you know, somewhere in, you know, Facebook's code base, they probably have classes that say, okay, a user has a name, maybe a first name and a last name, or a family name and a given name. You know, a gender, if we can determine that, or if they decided to share that information with us. An age, how long since they've last visited the site. How many times they tend to come on the site per month. I don't know, right? These are just things that I would guess that Facebook is storing about every single user on the site. Facebook probably also has an object that represents a post. You know, what do I know about a post? How many people have liked it? What are all the different reactions to it? Where has it appeared on the site? Who created it? Who's reacted to it? Who's responded to it, right? I probably have an object for each comment on a post, right? Which post is that comment attached to? When did that comment get made? Et cetera, et cetera. So, you know, one thing I would encourage you to do, you guys live in the internet age, as you start to look at the websites you're using, think about, you know, what corresponds, like what's an object or what's a class that corresponds or organizes information about what I'm looking at. And you can do this whether you go on sports sites, whether you go on news sites, whether you're, you know, on social media, whatever, right? You know, this type of organizational principle is incredibly common because it's incredibly useful. All right, so I want to stop here for today because the weekend's coming up. So on Monday, we're essentially going to do midterm review in class for the hour. I hope you guys will come because we'll go over some of the problems. What I want to do right now is walk you through sort of a little bit of what I would suggest would be a good way of approaching some of the programming problems on the midterm. So the midterm format is going to be identical to what you guys have been doing on the quizzes. There'll be a series of programming problems. Those programming problems will be drawn from, they won't be identical to, but they will be very similar to the practice problems that we've been releasing, the homework problems, and then the quiz questions. At some point today, I'll check to make sure everyone is taking quiz 3, and as soon as I know that that's true, I will take the programming problems to this quiz 3 and I'll add those to the homework set as well, right? So I want you guys to have lots of examples of things to practice with, but how do you do that? So let me go through an example. Okay, I have to stop. So by the way, please don't try to follow along here. I'm worried that we'll crash Prairie Learn if we do that. With 900 of you guys, and there's probably people taking a quiz right now. So let's just not do that. Just watch, all right? So this is one of the functions. Let me try to make this a little bit bigger. All right. So this is one of the recent homework problems. And the question is, write a function called arraySum that returns the sum as an int of all the values in a two-dimensional array of int values, right? So whenever you're preparing for an assessment, you want to try to do it in conditions that are as similar to the kind of conditions you're going to face in the testing center. So if you really want to go all out, you could buy like a really run-down computer with a really bad keyboard and set it up in the corner of your room to simulate the CBTF computers, is what I've been told about them. It's probably going a little too far, but for example, don't look up stuff online. You can't do that in the CBTF. So you can't go peek at your old homework problems. That won't work, right? You're also going to be under some time pressure. So set a timer for 10 minutes. Say, this is as long as I'm going to spend on this. You know, time management when you're working on these problems is really important. We typically have, 4 of them on the exam. If you get wedged on one and you spend 50 minutes trying to correct some sort of small problem, you will never get to the others. And maybe you could have done those more easily. So at minimum, I would say for a first pass, budget, 5 minutes, do as much work as you can. If you get stuck, save your answer and go on, right? That way you get to all of the problems. Okay. So the first thing I would do if I was preparing, there's actually 2 parts to this, right? First thing is I would try to solve the problem, right? Let me see if I can do this one, right? So I'm supposed to, it's called arraySum. It's supposed to return an int. It's going to get a 2-dimensional array. All right, so the array may be null, so I'm going to check for that. It says to return 0. Otherwise, I'm going to say length, I++. Now, I know that the array might be non-rectangular because the problem said that. j++, all right, I need a sum. Set that to 0. Sum plus equals array I, j. I think I'm almost done. I just need to return the sum. All right. Let's see if this works. Do you have a minute to think about things here? Good. OK. Thank you. That's not why I'm doing this, OK? I just needed a solution to the problem. But yes, I can solve my own homework problems. Thank you. I feel so validated. OK. So now you've solved the problem. But you're not done. All right? Now, if you're practicing for the quiz, you can go through and solve the problem, so just move on. But here's what I would do if I were you. And we do this to test the problems before we release them. OK? Make a small mistake. So let's make a small mistake, shall we? Of a kind that I've seen before. That's a tiny little error. It looks so similar, right? Semicolon and comma. OK. So because this is what's going to happen to you when you're in the testing center. You're going to do something dumb like that. It's just a tiny little typo. But if it takes you half an hour to find, you're in deep trouble. OK? All right, so my code crashed. I have syntax errors. OK. So one thing I do want to share with you is that we did fix this. So now you will see the compiler errors when this happens, right? I didn't fix it for this problem yet. I'll go do that later today. But in the future, what will happen is you'll see, we'll try to run the compiler, and what it's going to say is, like, there's something wrong on line 6, OK? So I'm going to go up to line 6, and I'm going to start looking through this. And I'm going to say, what is going on, right? And I'm going to go character by character by character. I'm going to squint at it. I'm tired. I've been doing this. This is my, 13th attempt. OK, there it is. So small mistake. Make a small error. Here's another example. Common mistake. I forgot to check for null. OK. So this is actually going to be better because it's going to compile. And it's going to run, and it's going to die. I hope. There we go. Yep. All right, null pointer exception. One of the things that, maybe I should be doing a better job of trying to teach you guys how to do, we might start putting some questions on the homework about this, or on the quizzes about this, is fixing errors. Look, I spend a lot of my life doing this because I make mistakes all the time. What I'm better at than you is fixing them, and that comes with practice. But figuring out how to consume these error messages is super important. OK, so it says there was a null pointer exception. So that's one really important piece of information. What other pieces of information do I get here? It actually tells me the exact line where this null pointer exception took place. OK? It's on question.java line 4. And I go up here, and I say, it's actually right here. This I need to fix. All right, so it tells me around this right point in the program to look at. All right, so something went wrong. Like line 3 or line 4, there was a null pointer exception. So whenever you have a null pointer exception, the thing to look for is dot notation. Where was the null that I tried to dereference? So in here on line 3, I can say, OK, I used array.length. What happens if array is null? To go back and look at the problem description. The problem description said array may be null. How do I check for that? And this is something that some of you guys struggle with on the last couple of homeworks, but I think we're figuring this out. I check if array is null directly. This is the way to check for null. You don't check dot equals null because that tries to dereference the object. I just check if array is null. What does it say to do? Return 0. All right, here's another one. Let's try this. Or actually, hold on. One of my favorites. OK? Going the wrong direction here. What's going to happen now? I fixed my null pointer exception. I've got some other problem. All right. You can see, again, I've got an error. Array out of bounds exception. It tells me the index that was wrong. Again, it also tells me the line number where this happened. So right here, I tried to use the index -1. Again, so I would strongly suggest, if you've been having trouble with the quizzes, that you perform this kind of practice. It'll be super helpful. One last thing as you guys are packing up, and this is actually important because this is going to be on the midterm. There will be one question on the midterm that's going to look like this. Okay? There's a question on today's homework that looks like this. We're going to give you a function, then we'll ask you to describe it in English. There is someone who's going to grade all of these by hand. Not me, actually. So this is one of the questions. Someone is going to hand grade it. It's on today's homework. It's going to be similar to this on the midterm. So use today's homework to practice. If you have questions about what the right answer is, we will talk about it on the forum over the weekend. I have office hours starting now. Have a great weekend, guys. Good luck on MP2. I will see you on Monday.